Now, remember that I told you, I sent you in the presentation that the formulas that we will be using for this are the exact same that we use for mirrors, okay? So there are no new formulas. The only thing that is going to change is the sign conventions for lenses and the ray diagram that we will be doing, okay? Take a look. We have, let me see, 11.1 physics, okay. Okay, so it says, a round object is placed 30 centimeters in front of a converging lens, which has a focal length of 10 centimeters. Find the image distance and the magnification. Describe the images. Okay, so let's see. Sorry, I need to organize this a little bit better. This is the real reason why I truly miss my laptop. It's because it doesn't occupy too much space. And here having the TV right on my desk doesn't leave me enough space to work. So that's why I truly miss my laptop. Let me see. Okay, so we're talking about a round object. Remember what I said about the thin lenses. The thin lenses have focal point in the two sides of the lens. As you can see in the ray diagrams that I shared with you, you have the focus, the focal point right there in front, but also in the back of the lens. And it happens in every single example. As you can see, focal here, focal there, focal here, there. Front, back, and front, back. Okay? So in all these ray diagrams, we're going to have to trace or to locate the focal point in the two sides of the lens. So the first thing that we need to work is we need to work with the equations. Okay, we need to work with the equations. And let's see, what is the information given in this problem? It says that the object is placed 30 centimeters in front of a converging lens. Okay, so we start by writing the data. So my object, remember this, the object is equal to P. And this object, which is a round object, is placed 30 centimeters in front of the converging lens. Now, it says that the lens have a focal has a focal length of 10 centimeters. So here, the focal length is equal to 10 centimeters. They're asking me to find Q, and they're asking me to find the magnification, and it says that I have to describe the images. Okay, I have to describe the images. So let's focus on the first part. I need to find Q. You already kind of know that the formula that we must use is the same that we use for the mirrors, okay? So in the first step, what we're gonna do is we need to find the position of the image, or Q. Okay, that's going to be the first step. I'm gonna move this a little bit here. because I want to keep all the information available here. Okay, so to find Q, remember that we use a formula that I already gave it to you. It's already isolated for Q. The one that says 1 over Q is equal to 1 over F minus 1 over P. Remember I gave this formula to you? Now, because it says that the object is placed in front, the 30 centimeters are going to be positive. Okay, that's why I wrote this over here. Because remember, it's placed in front. So let's see, let's apply the formula. And we say 1 over Q is equal to 1 over the focal, which is 10, minus 1 over the object, that is 30. Okay? How much is this? Give me the exact
1 over 15.
1 over 15. The exact fraction is 1 over 15. So now we apply the reciprocal function, and we say that Q therefore is equal to 15 centimeters. Now, in the second step, I will find the magnification. Okay, I will find the magnification. Now, the equation that we use for magnification is the same. So let's continue. Sorry, I'm moving this bit, but I need it, okay? Or at least I need that you see it right there. Now, to find the magnification, I already gave you a formula for it, which is magnification equals negative Q divided by P. This is negative 15 divided by P, which is 30. The magnification gives us equal to negative 0.5. Remember, these are centimeters each, but in the end, you cancel the two. The 2 units you cancel, okay? So this magnification, what can we say about this magnification? It is negative, okay? What does the negative tell us? How is the image that is going to be formed? Is it going to be inverse or is it going to be upright? Guys?
It will be inverted.
It's going to be inverse. What else does a negative mean?
It will be behind.
But the negative means that the image is going to be real or virtual.
Virtual.
The negative means that is a real image. I gave you this table. Let me bring it to you. No, not this one. Is maybe this one, the table. Let's see. No. Hey, we have done a lot of things about mirrors now that I see it. Okay, here is the sign conventions for magnification. Remember that magnification is quite different. Okay, so that magnification, negative means inverted, and negative means a real image. Okay, positive is a virtual image. So this negative, the other negative, I put it that is real image. I wrote inverse, but it's inverted or upside down. Okay. And then the other magnification thing that we need to analyze is the value. 0.5 is less than 1. So the image is going to be larger or smaller.
Smaller.
Smaller than real object. Okay? Okay, this is what we write about the magnification. This is very useful. So I write the conclusions for the magnification. Now I need to start drawing. To start my drawing, I need to analyze what is the situation that we have in this kind of exercise. So let's see. Let's see. So I have P, which is 30, F, that is 10. So I'm going to look for um, a common factor between the two numbers, okay? Because I need to start sketching. So I know that P is equal to 30 centimeters and that F is equal to 10 centimeters. What does the two have in common? By what number do you want me to divide?
5.
By 5. Dividing by 5 or by 10 is going to be correct. But if you divide by 10, the sketch is going to be very tiny. So I think it's going to be better if we divide by 5. So we say that we're going to be using a scale 5, 1, which means that we're going to divide each number by 5. So this gives us 30 divided by 5 is going to give us 6 centimeters measured with a ruler, and 10 divided by 5 is going to give us 2 centimeters measured with a ruler. Okay? So the first thing that I need to do is my axis. Okay? The axis where my object is going to be placed. There it is. Now I'm going to draw an axis for my lens, for my converging lens. Okay? And I'm going to do this axis, I'm going to do it in blue. Well, let me fix it a little bit. I'm going to put it there. Okay. So take a look to what I'm going to do right now. In that place, I'm going to draw a converging lens. Now, what is the converging lens? Is it the one that looks like an almond or the weird one? Is it like A or is it like B? What is the converging lens? How does it look like?
A.
Like A, okay? So this is the sketch that we're gonna do. Okay, so that's my lens. Sorry, it's not perfect. Let me see if I can stretch it a little bit. Mm. Bueno, no sé, ¿verdad? It doesn't look very nice. Okay, now take a look. I'm going to start counting from the center of the converging lens. That's my point, okay? I'm not going to start counting from here. It's from the center that we start measuring, okay? So first of all, I'm going to locate the focal point. Remember, I need to locate my front and my back, okay? So I will consider that this is the front of my lens, and I will consider that this is the back of my lens. So where is the object located? Is it in front or is it in back? Let's see. It says a round object is placed 30 centimeters in front. So in the front part, I will locate the round object. So my object will be placed in this side. So I'm going to place my object. But I need to place the points. I need my focal. So it says that the focal is 10 centimeters, so I will measure 2 centimeters. Or in my case, it's going to be 2 squares, okay? So this is my first and this is my second square. But I'm going to measure it at the two sides of the lens. First, second square. So those are the 2 points where I'm going to write my focal. Now, I will place my object. It says 6 centimeters in front. Remember, this goes in front. So I'm going to count 6 boxes or 6 squares in front. So I will count 1, 2, 3, 4, 5, 6. In this point right here, I will locate my object. It says that it is a round object, so I'm going to draw it. Sorry. I will locate it there. Okay. That's my round. I think it's just too big. I'm gonna make it smaller. Sorry about it. Okay, that's my object. Okay, so let's see how we're going to trace the rays. Take a look at the possible ray diagrams that we have. Let's see what configuration can we use for this exercise. What configuration is going to be? Remember that F is equal to 10 and the object is P is equal to 230. So, to what configuration does it correspond? 1, 2, 3, 4, 5, or 6? What configuration are we going to use? Bueno, if you don't know, it's okay. This helps you a lot to visualize how it's going to end, okay? But if you don't really do it, if you don't really use it, you still can follow me and trace the rays. Now I'm going to show you which one is and why. It's the configuration number 2, okay? The reason is because in the configuration number 2, we have F that is 10, the object is placed at 30, so the point 2F is going to be 2 times 10, making it 20. So in the end, the object is placed outside 2F, afuera del doble del focal, okay? So that's why this configuration is the one that matters. Now, let's see about the configuration. It says the image is real, also is smaller, and is going to be located between the focal and twice the focal point. That's what we really need to get. Now let's analyze. Real and smaller is exactly what we got here. Okay? Real and smaller. And you see that the object, the image here is upside down. So as you can see here, it's also upside down. So we're going to be using the configuration number 2. If you don't know how to use it, just follow me with the rays. Okay? So let's see. The first ray comes from the top of my object to the axis, to the y-axis where the lens is located, okay? Now, from there, you're going to look for the focal point, like that, okay? Then it says, remember that whenever you are in the back of the mirror or the lens, you have to do a dash line. Okay, so this is the first ray. This is the array number 1. Now let's work with the array number 2. It comes from the top of my object. It's going to pass through the center point like that. It's passing through this center point, okay? The one in the exact middle. Okay? So right now I'm just going to put this better. Remember that whenever you are in the back of the lens, you have to use a dash line. And now the third ray comes again from the top of my object through the first focal point until I touch the center, okay? The y-axis. Now let's see. Wait. Gosh. Okay, right there, from the top of my object until I reach the axis, okay? Passing through the other focal point. And then the image here goes straight horizontal. Remember that in the back of the lens, you will use dash line. Like that. So this is the second ray. And this is the third ray. So where is the object going to be located? The image will be located at this point, in the point where the three rays meet, which is right there. So right now, my image is going to be smaller, as you can see. Now let's analyze if it makes sense. The object is upside down. Yes, it's below the x-axis, so it is upside down. It is real image. Yes, it's real image because it is negative, and negative means behind the mirror, okay, in the back of the lens, sorry. So it is in the back of the lens, so that's good. And it says 0.5, the magnification means that is smaller than the real object. But how smaller, okay? We need to analyze how smaller. So remember that I gave you a formula that says h prime equals h times the magnification. So I'm not giving you the height of the object, but as you can see, my real object, I use a height of 4 squares, okay? 4 squares. Now, let's see if it makes sense. H prime is equal to h, that is 4 squares, times the magnification that gave me 0.5 negative. So h prime h prime gives me negative 2. Negative 2 means that it's below the x-axis, and the 2 means the size. The size should be 2 squares. Does it have the 2 squares? Does it measure 2 squares? Does it measure 2 squares or no?
Yes.
Yes. So when you draw the objects, if you use the right scale, everything will match. Okay? So yes, it makes sense. With this analysis that we did, we conclude that the procedure that we did was correct. Even though I didn't give you the size of the object or the image, I didn't give it to you. In the end, that's something that you decide when you are doing the sketch. But you can test if what you did is right by applying the same formulas, by analyzing the answers that you got. Now, another thing that we can compare is the distance of Q. It says that Q is located 15 centimeters, okay? The image is located 15 centimeters. Remember, each square measures 5. So let's see. How many squares do I have between my y-axis and the center of my image? I have, as you can see, 3 squares. So in the end, this is like the same as having 3 times 5, which makes 15 centimeters. 15 centimeters was the Q that we got at the beginning of the exercise. So with this comparison, we can tell everything that we do is correct in this exercise.